Hey guys, welcome back. Today is our second lesson, geometry. Before we get started, I just want to review what we did last time quickly. So first, a point, if you remember, is a dot indicating a place or position. So an example is point K, which can be illustrated like this and written like this. A line is an infinite set of points extending in two directions. So these arrowheads represent that the line is going on indefinitely in two different directions. And we can write this as line VW or line WV. A plane is an infinite set of points extending in all directions, which can be illustrated like this. Like I said last lesson, this is not a complete representation of a plane because a plane has no boundaries, but we have to include boundaries in order to illustrate it. And it can be written as plane XYZ, plane YXZ, plane ZXY, etc. As long as you have three different points that are not collinear. A line segment is a set of points consisting of two endpoints. So the points C and D are the endpoints, which have an infinite number of points in between them. They do not go on forever. It can be written as a line segment CD or a line segment DC. We also learned about a midpoint of a line segment, which is the point of the segment that divides the segment into two congruent segments. So what that means is if we have segment PO and point M is the midpoint, then segment PM and segment MO are congruent. And if you remember, congruency means that they're equal in length. So segment PM and segment MO are equal in length. Bisector of a line segment is any line or subset of a line that interacts with the line segment at its midpoint. So say we have segment FG and its midpoint is M, point M. Line TU here interacts with point M, which is the midpoint of segment FG. So we can say that line TU bisects segment FG. So here are some new terms to know. So building off of what we did last time, we have array, which contains a point on a line and all the points on one side of that point. Opposite rays, two rays of the same line with a common endpoint and no other point in common. An angle, which is a set of points that is the union of two rays having the same endpoint. So when we're drawing an array, we have an endpoint, which here is point D, and we extend this indefinitely in one direction. So unlike a line, it does not extend in both directions, it just extends in one direction. This can be written as ray DE. It cannot be written like this. It cannot be written as ray ED. This is because the starting letter when writing array should be the endpoint, which is D. So this is incorrect. Next, we have opposite rays. So the points on opposite rays are collinear. If you see here, ray HJ starting from H and extending this way, and ray HI starting from H and extending this way, are opposite rays. They share a common endpoint, but they extend in two different directions. All 3 points are collinear. Next, we have an angle. An angle can be drawn as two rays with a shared endpoint, which is the vertex. So in this particular angle, point A is the vertex because it is where these two rays meet. And X over here is the angle itself. So an angle can be written in many different ways. For this figure specifically, it can be written as just angle A, or angle X, or angle CAB, with the vertex in the middle, or angle BAC, again with the vertex in the middle. So here we have 4 types of angles. First, we have a straight angle, which is a union of opposite rays with a degree measure of 180. So here, opposite rays are ray LN and ray LM. So notice how both of these rays start with L, point L. Remember that the starting letter of a ray has to be its endpoint. Since these are opposite rays, they share the endpoint. So this is why they both start with the letter L and extend in 2 different directions. The angle created by this union of opposite rays is the angle of 180 degrees, also known as a straight angle. Next, we have an obtuse angle, which has a degree measure greater than 90, but less than 180. So here we have angle QOP, angle QOP. And this angle, if it is obtuse, should be greater than 90, but less than 180. Sorry, my mouse is lagging. So an example of an angle could be like 110 degrees. Sorry about the horrible handwriting. My mouse is not working at full speed right now. Next, we have a right angle, which has a degree measure of 90 degrees. So angle angle TRS S is equal to 90 degrees. And you can see that this angle in the figure is represented by a box. So all right angles are represented by this box, which basically means that ray RT and ray RS are perpendicular to each other, which is the same as saying they create a 90-degree angle. Finally, we have an acute angle. So acute angle they have a degree measure less than 90 but greater than 0. So angle Y, W, X is greater than 0. Greater than 0 and less than 90. So an example of an acute angle could be the angle 45 degrees. One more thing before we move on, I'd like to kind of review on how to name angles. So this obtuse angle, angle QOP, can also be written in multiple different ways. It can be written as angle O. It can be written as angle POQ as well. This right angle can be written as angle R, or also angle SRT. And this acute angle over here can be written as angle W, or also angle XWY. Okay, so now that we know 4 types of angles, we're going to move on to see if we can apply any of the vocabulary and terms we learned. So here we have question. So we're given that D is a point in the interior of angle ABC. The measure of angle ABC is 15, and angle DBC is a right angle. And we have three tasks. Find the measure of angle ABC, name an acute angle, and name an obtuse angle. So first, let's list our givens and see what we can conclude from them. So D is a point in the interior of angle ABC. So this is right here, angle ABC, and D is on the interior, which means the inside of it. The measure of angle ABC is 15 degrees. So let's write that down. Angle ABC ABD. Sorry. The angle of ABD is 15 degrees. ABD equals 15 degrees. So we finally have the information that angle DBC is a right angle. And this can also be concluded with the box right here. So what does that mean if angle DBC is a right angle? That tells us that its measure is 90 degrees. So our first task is to find the measure of angle ABC. So we have the measure of angle ABD, which is right here, and the measure of angle DBC, which is over here. So these two angles, they share a vertex at B, meaning that if we were to add these two separate angles up, we would get the whole angle of ABC. So let's do that. Writing it down, ABD, angle ABD, plus angle DBC equals angle ABC. My mouse is lagging again. So just plugging in the values, 15 degrees plus 90 degrees equals equals 105 degrees. So that was number one. Our next task is to name an acute angle. So if we remember the definition of an acute angle, it is an angle that is less than 90 degrees but greater than 0 degrees. So looking back at the information we gathered from part 1, we can see that angle ABD is 15 degrees, and 15 degrees is less than 90 degrees and greater than 0 degrees. So we can conclude that angle ABD is an acute angle. For part 3, it asks us to name an obtuse angle. So we must find an angle that is greater than 90 degrees, but less than 180 degrees. So we know that angle ABC, which we solved for in part 1, is 105 degrees. And that fulfills the definition of an obtuse angle. Angle ABC is obtuse. Okay, we have one more question for this lesson. So we're given a figure, and for this figure, we are asked to name two pairs of opposite rays, name two straight angles with vertex E, and name two angles whose sum is angle ABC. So, tackling the first part first, name two pairs of opposite rays. So, if we remember what an opposite ray is, it's two rays that share an endpoint and extend in two different directions. All three of their points must be collinear. So, looking at this figure, I can see that there should be opposite rays here and opposite rays here. So, ray ED and ray EB are opposite rays. They share endpoint E and extend in two different directions. So, ray ED and ray EB are opposite rays, and angle ray EA and ray EC are also opposite rays. EC are opposite rays. So this was part 1. So for part 2, it asks us to name two straight angles with vertex E. So we know that opposite rays are connected to straight angles because opposite rays actually produce 180-degree angles. So we can just take ray so we can take angle AEC as a straight angle, and angle DEB as a straight angle. So the vertex is E, which means that it's a shared endpoint. And just to draw in the angles, we could see an angle here totaling 180 degrees and an angle here totaling 180 degrees. For the last part, part 3, it asks us to name two angles whose sum is angle ABC. So we see angle ABC here, and we are trying to find two angles that, when added, equal ABC. So these angles should have a common vertex, because in order to add angles together, they must have a common vertex. So looking at this diagram, we can see that angle ABE over here and angle EBC here both share vertex B. So when added up, those two angles will equal angle ABC. So angle ABE plus angle EBC equals angle ABC. That's it for today. I'd just like to apologize for my horrible writing. My mouth